How are you doing, math learners? This is your free access math teacher Ash, and welcome to ML with Sir Ash. For today's lesson, we're going to discuss the last topic about geometric sequences, and that is all about geometric series. So before anything else, hit the subscribe button and notification bell for you to be updated of the School Clear Math videos just like this. Hello math learners! Welcome to another session here in Math Learning with Sir Ash. Today, we're going to discuss the most essential learning competency-based lesson for Quarter 1, Week 4 of the Grade 10 Mathematics, which is the last part of the topic geometric sequence, and that is the geometric series. Now, remember our lesson about arithmetic series? When we talk about series, it is the sum of the given sequence. So, in geometric series, we are talking about the sum of a geometric sequence. Therefore, in getting the geometric series, if the given geometric sequence is there, what you will do is you just add all the given terms and you get your answer. However, there are times that the geometric sequence is not complete, meaning an ellipsis has been used. There are what we call the finite sequence and the infinite sequence. The finite sequence is an ending sequence. However, an infinite sequence is a continuous sequence. So, how do we solve for the geometric series? Now, let us consider some examples. Okay, math learners, for our first example, we have 3, 6, 12, 24, and so on and so forth. The problem is, find the sum of the first 10 terms. The term sum means that what the problem is asking is the geometric series. This is a geometric sequence, and the idea in which it asks for the sum, that is already a geometric series. Now, how do we get this? Technically, there are two ways. The first is to name all the 10 terms. You have already the first 4 terms, and if you continue this until the 10th term, then you add all the terms, you have your geometric series. However, that will be very tiresome for you, right? So, what do we do here is we tend to use another technique. What is the technique? We will use a formula. Now, the formula for the geometric series is S sub n is equal to a sub 1 times 1 minus r to the power of n over 1 minus r. Now, what do we do here is we just change or we just substitute all the given. Okay. The first term is already given here, right? Okay. However, we don't know the ratio, the common ratio of this sequence. Remember, in getting the common ratio, you could just ask yourself, what happened to this? Why it became 6? Okay? So, 3 is multiplied by 2 in order to get 6. Other way is by dividing the latest to its previous. That is 24 divided by 12. That is also 2. Therefore, the common ratio is positive 2. Okay. So, by just substituting, we have a sub 1 that is 3. Then 1 minus, our r is positive 2 to the power of n. So, what is our n here? The problem is 10 terms. So, we will use 10 as our n over 1 minus 2. So, what do we do here is we solve first using PEMDAS. So, we have 3, okay? Then 1 minus 2 to the power of 10. What is 2 to the power of 10? 2 times 2, 4, times 2, 8, times 2, 16, times 2, 32, times 2, 64, times 2, 128, times 2, 256, times 2, 512, times 2, that would be 1024. Okay, so that is 1024. 1 minus 2, that is negative 1. Okay, so we have here 3 times 1 minus 1024, that is negative 1023. Okay, and then divided by negative 1. So if we continue, we multiply this one, so that is negative, so that is negative 9 here, 6 here, 0 here. Okay, 3,069. Okay. divided by negative 1. Both are negative. So therefore, cancel the negative. 3,069 divided by 1. And your final answer is 3,069. And that will be the sum of your first 10 terms of this given sequence. Easy, right? Now, let us consider another example. Okay, math learners, we have here our second example. We have find the sum of the first 7 terms in the geometric sequence, 3, negative 6, positive 12, negative 24, and so on and so forth. Now, the question is, what is the sum? Okay, so since we are talking about sum, we are talking about geometric series. How do we get that? We just use our formula. Now, what do we need in our formula is our a sub 1, right? Our a sub 1 is 3 and our n is 7 because we are talking about 7 terms. And our r is not yet unknown or not yet known. So, how do we get our r? We divide the latest to its previous. So, that is negative 6 divided by 3, that is negative 2. If you try this one, 12 divided by negative 6, that is still negative 2. Negative 24 divided by 12, that is still negative 2. Okay, so now, let us use our formula. That is, S sub n is equal to, our a sub 1 is 3, 1 minus r to the power of n, that is 1 minus negative 2 to the power of 7. Okay, since we already have a parenthesis here, this outer parenthesis will become a bracket. Okay. Over 1 minus negative 2. Okay. So, what do we do here is we just simplify. So, we have 3, then here, then 1 minus negative 2 to the power of 7. Now, remember that if your base is negative and you have an odd exponent, the final answer is negative. Okay. So, let's just use 2 to the power of 7. 2 times 2, 4 times 2, 8 times 2, 16 times 2, 32 times 2, 64 times 2, 128. Okay, so that is 128. Sorry. Okay. Then, 1 negative negative, that will become plus 2. Okay. So we have here 3. Now we have 1 minus negative 2, that will become plus. So, 1 plus. Okay, so that is 129 over 3. So, 3 and 3 here can be cancelled. So, your final answer is 129. So, that will be the sum of your first 7 terms in this geometric sequence. Easy, right? Now, let us go to the final example. Okay, math learners, for our final example, we have find the sum of the first 6 terms. Okay? If your first term is 40 and your common ratio is 1/3. Okay, now, what we do here is we just follow our formula. That is S sub n is equal to, now, our first term is 40 times 1 minus r to the n. Okay, 1 minus r to the power of 6. Okay, to the power of 6. So, we are using a parenthesis inside. Therefore, we use bracket outside. And then 1 minus 1/3. Okay. So this may be very challenging because we are considering fractions. So what we do here is we have 40. Then 1 minus. So 1/3 to the 6th power. That is 1 over. So 3 to the 6th power. Now this may be very challenging. 3 times 3 is 9. 3 times 3 is 9. So we have 9 times 9. And we are considering 6, so another 9. So this is 2, 3, 2, 3, and 2 3s, right? Because 3 times 3, 3 times 3, and 3 times 3. So this is 81, right? This is 81. So we have 81 times 9, and that is 729. Okay, so over 729. And then we have here, close. Then 1 minus 1/3, of course, 1 whole minus 1/3, that is 2/3. Okay, so, question is, how do we simplify this one? Now, what we do here is, we subtract this first. This will become 1 minus 721, 29. That is 729 over 729 minus 1 over 729. Because we will change our whole number into the same value for the denominator. Okay. over 2/3. So the final answer here will become 40 times 729 minus 1, that is 728 over 729 over 2/3. Okay. Now, let us continue here. So we have 40 times 728 over 729 divided by, because that is over 2/3. Okay. So remember, in dividing fractions, we have 40, 728 over 729 times 3 over 2. Now, as you can see here, this is a whole number, a fraction, and a fraction. You can use the cancellation. Okay. So 40 and 20 here can be cancelled out. This will become 1. This will become 20. Okay. So let's try if this can be cancelled out. So 729 divided by 3. That is 2, 6, 12, 4, 12, 9, 3. Okay. It can be cancelled. So therefore, this will be cancelled. This is 1. And this will be 243. So that is 20 times 728 times 1. So that is 20 times 728 times 1. Let's not just write that 1. And then 243 times 1. Okay. So simplifying this one, we have 728 times 20. 0, 16, carry 1. 5. Okay. And then 14. So that is 14560 over 243. Now, question is this divisible by 3? Because we all know that this is divisible by 3, right? So, let's try. Okay. So, let's check whether this is divisible by 3. Oh, it is already 0. Let's still try whether we can do this one. Okay, so this is 4, 12, 25, 8, 24, 16. That would give us 5, 15, 10. Okay, so this is not divisible by 0. Therefore, this will be our final answer. Is it right? So, this will be our final answer. Hope you got that one correct, my dear math learners. So, this is now the time that I will challenge you whether you have understood our topic for today. And here it is. Okay, math learners, I hope you have a fun time learning about geometric series. This is still your free access math teacher, Ash. And always remember, it is fun to learn mathematics if we are together learning. Thank you so much, God bless, and stay safe always. Congratulations, math learners, for arriving to this part of the video. If you think that this video have helped you, click that like button. And if you think that this channel can change the way you see mathematics, do not forget to click that subscribe button and notification bell. Thank you.